I'm Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is a error detection. The outcome after the completion of this session, or after completion of the topic, the student can able to learn error detection, which ensuring the data integrity by identifying the corrupted data, allowing for other corrections and retransmissions. He can able to learn to enhancing the reliability, efficiency and security in data communication and processing. So this is the outcome of the error detection. Types of generally in data other communication, the error, when will arise the error means now, if the sender sending one source of the data, if it is same data is not received by the receiver, generally this error will be arised in a data other communication. That means it may be the local other communication or other global communication from one state to another state, one country to another country. So any other communication, if it is not the received the correct data, that error will be arised. That means here types of this in which error the detection, different types of the errors will be arise during the other communication. Generally in a computer network subject here, there are mainly three types of the errors will be considered. What are the three types of the errors means? First one is a single bit error. That means if the sender sending the data 10110011, so this is the sender sending data. The receiver receiving data is 10110111, three ones. Here instead of 0, only the single bit is received different. Whatever the message is sending by the sender, the receiver not received the same message. He is received the different message, in which here only one bit is different. If it is receiving bits, in a receiving bits, if only one bit is the differ, such type of the errors now we can call it as a single bit errors. In a framing, there is only one bit anywhere here through which is the corrupted. Only one bit is is corrupted in a single bit error transmission. Multi-bit error. Multi-bit the error transmissions, multiple other bits. That means here 2 bits. If it is 2 bits are the corrupted, whatever the data is sending by the sender, in this sender data, if 2 bits are the corrupted, if 2 bits the corrupted bits is received by the receiver, now we are saying it as a 2-bit error or multiple other bit errors. That means here multiple bit errors means now the sender sending the data as 10110011. So this is the sender sending information. At the receiver side, receiver received instead of this 10110011, he is receiving 10100111. Different as the bits are received. Here he is received with more than 1 bits are corrupted. More than 1 bits are corrupted. That means 2 bits are corrupted here. One is bit 0 is the corrupted here, and another one is bit 1. That means here instead of this in a sender here, instead of 1, the receiver receives the 0, and the instead of this 0, the receiver receives the bit other 1. These 2 bits are corrupted, bit 1 and bit 0. These 2 bits are corrupted. So this is the multiple bit error detections. Here next, burst errors. Burst error means here If it is more than one bits are the corrupted. So that the corrupted the information, now we are saying it as a burst error. Here, if for example, if the sender is sending the data 1011 so from each here more than one bits are other corrupted. That is 10000111. Here, whatever the sender is sending from this more than one bits are received different bits. That is the corrupted bits are received. These three bits are other corrupted. Here, instead of the 011, the receiver receives the 100. Here is the more than one bits are other corrupted. So these are all the different types of the errors can be detected while communicating from one device to the another device. So this type of these errors can be detected. Mainly this type of errors can be detected while communicating from one device to another device. Here, generally, mainly these are the error control mechanism which is involving two possible ways. First, now which is detecting the errors while communicating between the two other devices, now which is detected the error. Different types of these error detections: one bit error, multi-bit errors, or burst errors. One bit error means now the receiver receives only one bit is the corrupted data is received, whatever the sender sent. And multi-bit errors means here 2 bits, more than 1 bits. So more than 1 bit the corrupted data is received. That errors, now we are saying it as a burst errors. Like this, now errors can be detected. Whatever the errors detected, so that can be corrected by using the error correction mechanisms. Here, error detection. Error detection mainly what it is doing means now, which is identifying the errors. If any errors has occurred during the data transmission or data storage while communicating between the two different devices. So it is not specified where the error and how to correct it. Only error detection method now, which is detecting the error. Error messages are received, now which is detect the error. Some common error detection methods for this one, whatever the data you are transmitting, in this data transmitting, some common error detection methods are the parity check and checksum, cyclic redundancy check, that is a CRC, and Hamming distance. These four are the common error detection methods. So it can be used. By using these other methods, errors can be detected while communicating between the two other devices. Parity check. First, the error detection method is a parity check. So this is the parity check. Now we can call it as a single parity bit. The parity bit the check here. So it is a simple error detection mechanism. Single parity bit is a simple error detection mechanism. So that means now in which only the single bit error can be identified. Parity check, with help of this the parity check, single bit error can be identified. So here is in this the mechanism where an additional bit can be added, that whatever the data is transmitting from the sender side. For the sender side of the data, now we are adding the additional bit. Suppose if we are transmitting the data 1001001 at the receiving side, now received it as 1001001. One more bit is added here. So this adding bit, now we are calling it as the parity bit. Here, if the number of ones here, the number of ones are the whatever the data the transmitting, in which the number of ones are odd bits. By adding this the bit 1 here, the number of ones will be the even. If it is number of ones are even, now it is we are seeing it as a even the parity. Once if it is the receiver receives the even parity, now it will be detected it has no errors. So the parity bit which ensures that the number of ones in a data which is including the parity bit is even. Now we are saying it as a even parity. Suppose if the number of ones are the odd, now it is detected as a odd the parity. Here the limitations, it can only detect on a odd number of the bit errors. If any odd number of the bit errors only, it will be detected. That is a odd number of the bit errors means now. So for example, that is a 1, 3, 5 errors, etc. These are all the odd number of the bit errors, but not a multiple of the even numbers. That means here even multiple errors, 2, 4 errors, etc. Here this is the data the transmitting. In this the data transmitting, the parity bit will be added. Checksum. Checksum is a error detection method. In this the checksum now is a value that will be derived from the sum of data bits. So in a block, checksum means here now the block of data can be divided into number of sub-units or sub-modules. So number of levels, the data can be divided into number of levels, and summing all these, whatever the data is divided as a block, all the divided data can be the sum. So that whatever the sum we are getting, that sum now we are calling it as a checksum. The checksum is appended to the data before the transmission. Whatever the checksum you are getting, that means the summation of the blocked data. The summation of the blocked data we are calling that the checksum. These are the checksum should be appended, added to the data before the transmitting from the sender. Again at the receiver side, the receiver what it will do here, which is calculating the new checksum. The receiver also calculating the new checksum, and the sender also calculating the checksum. By calculating the checksum, the sender transmitting the information. The receiver also know what will do now, which is also calculating the checksum and finding the errors from the receiver data and comparing it with the transmitted the checksum. By comparing it now, the errors can be detected. The limitation means now the checksum limitations, it can detect most of the errors but may fail for certain the combination of the errors. Most of the errors can be detected by these are the checksum, especially if the errors are cancel each other out. Here now if we see the checksum, so is the error detection method which is used by the upper layer protocol. So and is considered to be the more reliable than LRC, VRC and CRC. Now it is checksum is a more reliable error detection than the LRC. LRC means longitudinal redundancy check. VRC means vertical redundancy check. CRC means cyclic redundancy check. So it is a checksum is a better than these error detection methods. So in these are the checksum method. These are the method which is making the use of the checksum generator at the sender side and checksum checker on the receiver side. Here is now whatever the data we are sending at the sender side, which is dividing into the number of subunits. The blocks, number of the message, the data transmitted message can be divided into the number of subunits or number of the blocks. Subunit 1, subunit 1, subunit 2, subunit 3, subunit 4. And here, after dividing the number of the subunits now, we can calculate the checksum. How we are calculating the checksum means now summing all the subunit bits. So the subunit bit, subunit bit 2, it will be sum now, we'll get the checksum. And here, by adding this sum now, the complement, we'll get the complement of this other one here. The checksum, whatever the checksum we are getting, it will be added to the data, the original data, whatever the data you are transmitting, it will be add to that the original data. At the receiver side also now, is the receiver, it is again which is whatever the data which is received from the sender, the receiver also, which is dividing the data into subunits. Subunit 1, subunit 2, up dash number of other subunits, and again it is generating the other checksum. Here, and summation can be get and complement can be done. If the result is 0, no error, so that means the data will be accepted by the receiver. If the result is if it is not 0, now the error will be arise. The receiver, it will be rejected the whatever the data is transmitted by the sender, it will be rejected by the receiver. And here, if you see at the sender side, the data is divided into the equal the subunits of the n bit length. All are the equal subunits by the. So this division can be performed by using the checksum generator. Equally, whatever the data you are transmitting, that the transmitting data can be divided equally with help of the checksum generator. This bit is generally of the 16-bit length. Generally, we are using 16-bit length for the transmission. The subunit, number of the subunits, these subunits are added together and using the ones complement method. Adding together here, by adding together all these other subunits, now we'll get the checksum. And complementing, once complementing can be performed. The sum of n bits, the resultant bit is then whatever the resultant bit is get, it will be complemented. Now we are getting the result. Here, these are the complemented the sum. Whatever you are doing is called as the checksum. So it is appended to the end of the original data. Whatever the original data you are transmitting, so it will be added to the checksum will be added to the original data. By adding these the checksum to the original data, now that can be transmitted to the other receiver. Here is after the appending here and then transmitted to the receiver, it will be received. After receiving the data by the receiver, so the receiver now, which is receiving the data along with the checksum. So, which is the checksum is the passes to the checksum checker. Here is now we are using the checksum checker. These are the checksum or the checker, which is dividing the data units into the various subunits of equal length. So, whatever the data is received, the data will be the equal length, which will be divided as a equal length and adds all these other subunits. These are the subunits also contain the checksum of one of the subunits. The resultant bit is then the complemented. If it is the resultant bit, the complemented resultant bit is a 0, then it will be accepted. If the complement result is 0, so it will be accepted. That means accepting means there is no errors in the data. Whatever the data the sender is transmitting, no error will be arise. If the result is a non-zero, it means that here the data contains an error and receiver rejecting the data. It won't accept the data. So this is the checksum. For example, if the data unit to be transmitted as this is a data message or data unit 1010 or 10001. So 00111 So this is a data transmitted message. Here first these the messages can be divided into subunit 1 and subunit 2. It will be added by adding here 1 plus 1 is equals to 10. Sum will be considered, carry will be forwarded to here. 1 plus 0 and we'll get the 1. There is 1 is a sum, there is no carry, and 0 plus 0 is 0 and here 1 plus 1 is a 10 and sum will be, we can take and carry will be forwarded to here. Carry here carry will be forwarded. Here also now we are forwarding the carry. 1 plus 1. Again 1 plus 1 is a 10. So 0 now the 0 we can take the 0 here and carry will be forwarded. 1 plus 1 that is a 3, that is a 1. The sum is a 1 and a carry will be forwarded here. 1 plus 0 that is 1 and here 1 plus 0, that is a 1. So this is the sum. That is now these are the sum will be considered. This is ones are the complement. If you do the ones complement of whatever the sum we are getting, if you do the ones complement of that the sum, now we are getting the checksum. So that is a complement of the sum. Checksum now here in this the figure. Now whatever the other sum bits now we are getting. Now the complement, by complementing of this the bits, now we are getting the same length of the n bits. The same length of the n bits will be considered it as a checksum. So this checksum is added to the original data. Whatever the original data is transmitting by the transmitter, now this checksum will be added to that the original data. So along with the checksum and the data, the receiver will be received the data. Here at the receiver side, now the data transmitted to the receiver is like that. So this is the data message or the information. Now data, it will be transmitted along with the checksum. Checksum is nothing but a summation of the all modules once complement. And the receiver side also now same. The receiver also which is performing the same operation. The whatever the data is received now, which will be divided into the number of modules. So sub unit 1 and sub unit 2. So that is a 1 0 1 0 1 1 0 0 0 1 0 0 1 1 1 0 0 0 1 sub unit 1 sub unit 2. Now just we have to summing this one here, and sums are the complement. Sums are the complement here. The sums complement is the 0. So that means result, it means 0. That means whatever the message is received, it is a correct message. Suppose if it is not 0 here, the sums complement is not 0, it means the error is arised in whatever the data is transmitted by the sender. Next, the detection method is a cyclic redundancy check. Cyclic redundancy check also now, which is a error detection method. Now it will be detected the error whatever the data is transmitted. Generally, it treats the data blocks as a large polynomial and divided it by the generated the polynomial. One polynomial will be divides, it's a generator polynomial. From that other polynomial, the dividend can be considered. For example, now the bits can be generated from the polynomial the equation. How can you generate the bits from the polynomial equations? Means now that the coefficient value can be considered. For example, now if you take x to the power of 4 plus x to the power of 3 plus x plus 1. Here the coefficient of that other variable, now we will be considered it as a division, dividend. Here the coefficient of x to the power of is 1 and the coefficient of x to the power of 3 is 1. X square, there is no coefficient, that's why now 0 will be considered, and coefficient of x is equals to 1. So like this, now the dividends, now the bits can be generated. If it is upon this the receiver which is performing the same division, same with help of this bit conversion, the division operations can be done. The receiver also perform the same division operation. If the division operation, if the remainder is 0, if the remainder is a 0, now if it is no errors are, whatever the data is transmitted by the sender, no errors are present. So that means it will be accepted. The receiver is, if it is no errors in a data, it will be accepted. Suppose if it is remainder is not 0, now the errors will be arised. So it will be detected and corrected those whatever the errors is there with help of the cyclic redundancy checks. So for example, best example now, the sender. So these values that can be generated by the polynomial equation. So that is these values are 1 1 0 0. So the divisor is a 101. Now 101 into 1, that is a 101. Here now we are performing the XOR operation. By XOR operation now, so we'll get the result as if the 0 here, the 0 and 1, two different values. Now the result will be getting it as a 1. If the values are the same, the result is a 0. Here in XOR operation, 0 plus 1, two different values. Now we'll get the result as a 1. and here also 1 plus 0. These two are the different values. Now we'll get the result as a 1. 1, 1. Same values, result is a 0. So, and for whatever the result 1, 1 we are getting here, so it will be added. The remaining 0 here, it will be appended to 1, 1, the resulting value, that is 1, 1, 0. Again here 1, 1, 0 into 1, now we are getting 1, 0, 1. Again we have to performing the XOR operation here. Here we have to perform the XOR operation. Same. If the 2 bits are the same, the result is 0. If 2 bits are the different, the result is a 1. Here is 0 and 1. 0 XOR 1. 2 bits are the different. The resulting value is a 1. Here also 2 bits are different. 1 plus 1 XOR 0. The resulting value is a 1. 2 bits are, if the 2 bits are same here, if the resulting value is a 0. So 1, 1 now, this remaining 1 here, whatever the value is there in a, this is the polynomial generated bit here. So it will be appended. It will be appended to the resulting value 1, 1, 1, and again multiply 1, 0, 1 into 1. That is a 1, 0, 1 here, and resulting 1, 1 is a 0. These two are 1 XOR 1. 1 XOR 1, the values are same value, you will get the resulting value as 0. 1 XOR 0, 1. 1, 1, 0. Now remainder is a 1, 0. Remainder is the data bits now, remainder is a 1, 0. So this is the data bits. Whatever the data bits now, we are transmitting. Here the receiver side, whatever the remainder we are getting, same the division operations can be performed by the receiver. The divisor is the same. 1, 0, 1 is a divisor. The data here, the transmitted data is 1, 1, 0, 0, 1. So at the receiver side now it will be detected. The error is arised in this data transmitted or not based on the remainder. If the remainder is a 0, that means no errors are arised in the data transmission. Whatever the data is received, so it will be accepted and receiving the other data. Here, the same division operation will perform here 1, 0, 1 into 1, that is a 1, 0, 1. And XOR operation, if you perform the XOR operation, if the bits are the different now, we will get the result as 1. Here is 0 and 1, these two are the different bit. 0 XOR 1, the result is 1. 1 XOR 0, the result is 1. If the bits are same bits now, the result is a 0. Here, the remaining, the whatever the in the data bits, remaining bits, it will be appended to the result. This bit, 0 bit is appended, and we will get the 3 values. Why? Because the divisor having the 3 bits, 1, 0, 1. That's why 1 bit is appended here. And we are having the result as 1, 1, 0. And again, 1, 1, 0 is multiplied with 1, 1, 0, 1 into 1. That is 1, 0, 1. And here, the result we are getting by performing the XOR operation, 1, 1 result. So, whatever the result we are getting, the 1 will be appended here. And same operation, XOR operation will be performed here, 1, 1. Bits are same, 0. Result is 0. If the bits are different bits, result is 1. And here, 1, 0, you will get the result as a 1, 0. And whatever the 0 is there here, whatever the 1, the remaining 1, it will be appended to 1, 0, 1. 1, 0, 1 into 1, 0, 1, that is a 1, 0, 1. So 1, 1 are the same bits, 1 XOR 1, that is the result is the 0, and 0 XOR 0, same. If the bits are same, the result is 0. Here also, the bits are same, the result is 0. That means the remainder is 0, 0, 0, no errors. No errors. The data bits and the CRC. That means the receiver will be detect whatever the data is received, which is having no errors. Like this now, the errors can be detected. Advantages of this, the CRC, it's a very high effective at detecting the single bit, multi-bit and burst errors. So single bit means only the error is arising in a single bit. Multi-bit means in 2 bits more than the single bit now, errors is arising, that's the multiple bits. Error will be arising in a multiple bits. Burst error means here, the error will be arised in a more than 1 bits. That is a multi-bits. The applications of these error detection methods are used in a networking. Example, in a Ethernet, the Wi-Fi, the file the transmission system, and the data storage system. These error detection methods can be applied. Hamming distance. So what is the Hamming distance? Means mainly Hamming distance, it is a metric for comparing the two binary data strings. By using the Hamming distance, we can compare the two binary data strings while comparing the two binary data strings of equal length. In a Hamming distance, the binary strings should be the equal length. So if the binary strings, if it is equal length, then only you can comparison can be done. The Hamming distance will be applied to the equal length of the binary disk. So this Hamming distance is the number of bits, the positions in which the two bits are different. Here, if you see the Hamming distance between the two strings, A is a one string, B is a another string, and it will be denoted as D of A comma B. D of A comma B. Here it is used for error detection, error correction, when the data is transmitted over the computer network. So it is also using in a coding theory for the comparing the equal length data words. For example, is calculating the Hamming distance now. Generally, to calculating the Hamming distance between the two strings A comma B, now we can perform the XOR operation. By performing the XOR operation, the Hamming distance can be calculated, counting the total number of ones in the resulting string. So the total number of the ones in a resulting string, which is giving the Hamming distance. So suppose here, if you take the two strings 1 1 0 1 0 0 1 and 1 0 0 1 1 1 0 1. So 1 1 0 1 1 0 0 1 is a one string. So it is a and 1 0 0 1 1 1 0 is a string B. So by performing the XOR operation of these two strings, now we are getting the result as 0 1 0 0 1 0 0 0. So XOR operation means if the two bits are same, result is 0. That means 1 1 result is 0. 0 0 result is 0. If the two bits are different, the result is 1. So this is our XOR operation. Here is now we are getting, by performing the XOR operation to A and B, we are getting the result as 0 1 0 0 1 0. So in which number of ones are only 2, that is 1 and 1. Since the containing two ones, the Hamming distance of D of 1 1 0 1 1 0 1 1 0 0 1 1 1 0 1. Here in this result, number of ones are 2. That's why the Hamming distance is 2. Like this now, by performing the XOR operation between two strings, equal length of the two strings, the Hamming distance can be evaluated. If you want to calculate the Hamming distance, you have to consider the two same length of strings. Then only we can calculate. For this, the textbooks are the Data Communication and Networking, Tata McGraw-Hill's 5th edition, 2012, and the authors are the Forgen and Origin. Here is next to the Computer Networks, Princeton Hall, 5th edition, 2010, Tenenbaum. Author is Andreas the Tenenbaum. So these two are the textbooks for the error the detection methods. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.